Okay, at any point of time, if I am on mute, you're not able to hear me, or if you cannot see my screen, just let me know. Okay, I'll just start. So this was for week 2, and this the whole section is for week 3. So first, I want to discuss the slide. See, I was given instruction from the NPTEL that I am not supposed to discuss the upcoming assignments or the ongoing assignments with you all. Okay, so I have prepared some question. Uh, so which is similar to the assignment that you're going to get in the future. So I'm going to discuss those questions so that you get an idea how to solve the current assignment. Okay. Uh, so first of all, before that, has everyone gone through the slides? Any questions you have on these slides?
Slides of week 3, sir.
Week 3, yes.
Slides of week 3.
Yes. Slides of week 3.
Slides of week 3, sir.
Yes. Are you not able to hear me?
Hello.
Just hold on, hold on.
Ah, okay, sir. Yes, sir.
Oh, I think there is a lag, no? Just hold on. Holding. Yeah. So yes, slides of week 3. Hello.
Yes, sir.
Yeah, slides of week 3. Yes. Do you have any question in that? In the DAC or in the ADC or on the sensors? Are you clear how all these things works? Hello, anyone?
Sir, in successive approximation, ADC, sir.
Yeah, tell me. My
Hello.
voice is clear, no?
Sir.
My voice is not lagging, right? Is my voice
Yeah,
clear?
yes, sir. In successive approximation, ADC, sir.
Okay.
Yes, sir.
Yeah, tell me.
Lecture 14, sir. ADC part 2. In successive approximation,
Mhm.
how can we determine the number of cycles required to solve the problem, convert the digital to analog to digital signal, sir?
Yeah, so the number of cycles that it takes, right?
It is given in the slide, sir. For required to convert the n-bit DAC, analog signal to digital signal using n-bit ADC.
Yeah, right. You are telling about this N, right? Okay, yeah. So what it says is, I mean, the
Yes, sir.
maximum step is N. Okay. So what it says is the maximum number of steps are N.
Sir, are you sharing your slides?
Maximum cycles.
Yeah, you are not able to see that?
Yes, sir. Yes, sir.
Okay.
No, sir.
No.
Yes, the slide is not
You are
visible.
not able to see the screen.
Okay.
You are not able to see the slides.
Just hold on. I'll just come out. Yeah, able to see my screen now?
No, sir.
Still no.
No, sir.
Yes,
Yes, sir.
Yeah, just wait. I mean,
I think there is a lag, sir.
there's a lag, no?
Yeah.
Okay. Yes, tell me. So, yeah, tell me now. I hope the screen is visible and
No,
No,
sir.
we
At
cannot
least I
see the
can't see.
screen, sir.
So your screen is not visible, sir.
See,
I don't know what is happening. I mean, s-
Sir, can you left the meeting and join again?
yeah, I'll just try to do.
Okay.
Now is it clear?
Yeah, now it,
Okay, okay, okay. Yeah.
mm,
Sorry, guys.
oh,
Really sorry. Yeah, tell me. Yeah, so what was your question? I guess it is visible, right?
actually, your screen, you the screen is not there, but your
Slides is not visible, sir, but screen is sharing.
slide is not visible.
Why am I? Okay.
Log out one time and try one more time, sir. It will be
I'll
resolved.
try to do. You're sharing.
Share the screen.
Yeah, actually, I'm trying to do with this Samsung tab because I'm not at home right now. That's why. Hmm. Is it right now? You're able to see the screen, right?
yeah, screen is visible.
Okay. But the slides are not visible.
Now it is
And
there.
now the
Now it is
slide is
visible,
visible.
sir.
Okay, okay,
Visible,
great,
sir.
great, great, great. Okay, okay. Yeah,
Can you put it in the landscape mode?
I'll try. Yeah, yeah. Is it okay now?
Yeah,
Okay.
Okay.
Yes,
yeah.
sir.
Yeah,
Okay.
yeah. Tell me. So what it says is, I think someone asked the question, how many steps are required for the conversion? For example, the largest number of steps that are required is n.
Okay.
Okay, largest is n. So, are you clear why it is n? Is it clear to you?
Number of clock cycles.
Yeah, number of clock cycles, which is the same as, for example, the number of steps.
Mm.
So, yeah, so what it says is, for example, if you see, let's say you want to go from 000 to 1000, right? So the number of clock cycle that is taken is only one. But for example, if you have from here, you want to go to here, then the number of clock cycles that will be taken is 1, 2, 3, 4, sorry, 3, then 4, then 5. Okay, so this is the total number of clock cycles that are taken. So that way.
Sir, I can't understand. How can we calculate the clock cycle?
Yeah, see what happens is in the clock cycle,
Can you
what
give
you
me an example, some like
yeah, for
if we
example,
have a
let's say you start with 00000, right? You start with 0000. Then the first thing that happens is you compare this 0000 to your v in. Okay, now for example, if 0000 is less than v in, okay, so the first thing that you do is you from 0000 you go to 8. Now this value is 8, right? 1000. This is 8. So first you come to the middle point. It is same as searching in an array. So first you come to the middle point. Now let's say that your voltage is actually here. Okay, your voltage is actually here. So and this is 0, this is 15, this is 8. Okay, your voltage is, let's say, actually 3. Just one example. Okay, so what you do is first you start counting from 8. Okay, then you see whether 3 is less than 8 or more than 8. Since 3 is less than 8, so what you do is you from 8 you come to 4, which is 8 by 2. You come to 4. Okay, now again you compare whether 3 is more than 8 or more than 4 or less than 4. Since 3 is less than 4, what you do, you change the threshold. From 4 you come to 2. You are just dividing by 2, right? After that, what happens is, for example, now you check whether V in is greater than 3 or greater than 2 or less than 2. Since V in is greater than 2, so that's why you increment V in by 1. Okay, this threshold you increment by 1, and then 3 becomes equal to 3, and then you say, okay, my output is 3. My output is 3. So in the same way, so what you are actually essentially doing here is, for example, this is your range of V in voltage, right? It can be from 0 to, let's say, 15. So you pick one middle point, 8, and you check where is your V in voltage. Is it lying here or is it lying here? If it is lying in this region, you change the threshold. You come back to 4. Okay, you come to 4. Okay, then you check where is your input. If your input is here, then you come here. Okay, so what you do, instead of going from 8, 7, 5, 6 like that, you directly divide by 2 and then you check. So this is same as almost binary search. This is same as almost binary search. Okay, so let's take an example. For example, let's say that you have mm, the value that you want to compare is, let's say, 8. Okay, or not 8, let's say 7. Let's take the highest number, 7. Okay, so your first output is 8. Your first output is 8. Now you tell me whether 7 is more than 8 or less than 8. Hello?
Less than 8.
Correct. So it will follow this path, right? It will come here from 8, it will jump to 4. Now this is your next output. These are all outputs. Okay, these are all outputs. So it jumps to 4. Okay, now whether again you compare whether your 7 is greater than 4 or less than 4.
Greater than.
Greater than 4.
Greater than 4. So for you follow this path. Okay, now what is this? This is 6. Okay, now you compare whether 7 is greater than 6 or less than 6.
Greater than 6.
Correct. So follow you this path. So you follow this path. Okay, from
Why 6, sir? There.
this one,
Yeah.
this is 0110, right? This is a binary representation of 6, right?
No.
Hmm.
If 7 is sorry, if 5, you chose the number 7, no,
Correct. Let's say the input is 7.
and the half of 8 is 4. Then
Correct.
increment by 1 means 5.
No, no, no,
We
no.
have
You
checked
no, no,
5
no, no.
now.
I got it. I got it. But you cannot increment like this. See, in successive approximation, the way you increment is whatever number you have. For example, 0100 you have, right? So you put 1 on the next bit. So for example, if your current number is 0100, your next number is not 0101. Your next number is not that. Your next number is 0110. You put
Okay,
the 1
okay,
here.
okay,
Okay,
okay.
okay, okay. Yeah.
Yeah.
Okay, 6. So right now 6 is, now 7 is less than 6 or more than, it is more than 6. So you follow this path. Okay, now it comes to 7, right? Because the moment you put 1 on the last bit, which is after this one, it becomes 7. Now 7 is equal to 7, and then you stop the conversion. Okay, so it is very simple that, for example, if again I'll do, so for example, whatever number is, if you compare this with this threshold, if it is more than the threshold, you follow this path. If it is less than the threshold, you follow this path. Okay, so right now this number is what? This number is 10. For example, if I tell you that my V in is 11, so which path will you follow? This path or the upper path or lower path? Sorry?
Upper path.
Correct, upper path. No, that's the way this whole successive approximation works. I think someone wants to join.
Sir, I have a question.
Yeah.
Can
So
I ask?
Yeah, correct.
Hello.
Hello. Are you able to hear me?
Ha, ha,
Yes, go ahead.
yes.
Yeah,
Last time I had raised the question and there was a power failure, so I didn't get the answer.
sure. Tell me.
The same question,
Okay.
how the controller is getting the meaning of each instruction, whether the
Oh, okay.
instruction, and that is not clear to me, whether that
Okay.
mm, coding and the mnemonics are there and how it is making the sense that this is the code and I have to do the instruction as per this.
Okay.
As a,
So
is there any program or such
no, there is no
like?
program, but I will tell you how it works. See,
Ah, okay,
okay. First of all, you have to understand that you have to build up a hardware. You have to build up a hardware so that you can put software to it. Correct?
okay,
Okay. So this hardware cannot be made in the same language in which you are making the software. So let's say you're
okay,
making the software in C or assembly language, you cannot
hmm,
definitely make the hardware in that. Okay, so the hardware has
okay,
to be made in a different language, or as the name suggests, this hardware, it is just a combination of gates, right? It is just a combination
okay,
of gates, correct?
okay, okay.
So for example, let's say I'll just
But is there any as a software which is made in C? Has there any converter C to assembly language inside the controller?
no. See, what you do is you write the full program in C, right?
Okay,
After that, you say you compile.
okay.
You are doing it in the PC, right?
Compiler is making some program. Okay,
Correct.
compiler is in program.
Yeah, compiler is finally making, you can say compiler plus assembler converts the
Uh,
whole C program into string of
into
bits.
machine language
Correct.
binary.
Correct. Binary
Okay,
in 1010
compile
10.
compiler plus assembler makes
Correct.
the program in machine language, that is
Correct.
binary.
Correct. Yes,
Okay,
yes. Okay. Now this is something. Just hold on.
High level
Now,
language.
yeah. So this is which what we call as the bin file. Okay.
bin file. Okay.
Bin file. So this is the binary file. Okay. Now people
Hmm.
call it hex file. There are many other types of file. Okay. But essentially it
Hmm.
is the same. These are just machine instructions which are composed of bits. Correct.
Okay,
Okay. Now this you put in RAM.
okay.
Okay. RAM or ROM.
That that is program memory.
That is program memory. Okay. Yeah. So
Okay,
you put in, normally you can put in RAM also, you can put in ROM also. Now people say that you always put your program in ROM and all, but that's not the case right now. So you can put your program anywhere in RAM also and ROM
any
also. Yeah,
problems.
yeah.
Okay,
So the controller, then it does what? Now this controller is just a piece of hardware. Okay.
okay,
These, okay. So what it does is it fetches the first instruction. Now let's say the first instruction is 10110100. Now it means
o-
something. It means something.
okay,
Okay.
okay,
As per your C code, it means something. So this string of bits goes to some
hmm,
combination logic.
okay,
Okay. Now this is a logic hardware which is made of AND gates, NOR gates, and all those things. Okay.
okay,
Now this instruction is also going to many other combination logic. Now, but there
o-
is only one combination logic which will give output as 1, the others will give 0 for this particular bit pattern.
okay,
Correct. The moment it gives 1 for this particular bit pattern, that part of the hardware will get activated in the CPU, and CPU will, let's say, fetch the next instruction, and it will understand whether the next is an instruction or the next is a data, how do I put it into the register and all those things. But these are all part of the hardware. This is not a part of C code as such.
okay.
Okay, so right now, yeah, so this is my whole pitch. So you can ask me questions now, like in this whole process, where is your doubt?
Now, my doubt is that when it is selecting a particular port or
Hmm.
decoder is making sense of your instructions
Hmm.
that is there inbuilt in the controller,
Correct.
but decoder has to follow each instruction has to decode in that type of action has to take by the
Right.
controller
Hmm.
control action or
Hmm.
whatever the air arithmetic logic or data processing, whatever
Right.
it is, decoder will do the that type of work.
Right.
Okay,
Absolutely.
But that is not the program written somewhere. That is not program written.
No,
But
okay,
decoder will make the sense. But these many instructions, suppose there are in RISC architecture, suppose there are 52 instructions.
correct.
So okay, it will make sense to 52 type of works. Okay, as an example, it may be larger, but how the decoder is going to sort this type of works actually? 52 decoder lines are there, or what?
No, it is
I'm
not.
not.
No. It is not as simple as that. I mean, don't think the controller is having just one decoder hardware which will decode this 52 and just give one output signal. I just give one example of that. So, for example, there is some languages called Verilog and VHDL. You have an idea of all those languages?
Yes.
No, I'm having idea of C and assembly
Okay, okay.
instructions.
So,
Sir,
yeah.
in
So,
Verilog we can declare no, sir.
in Verilog?
In Verilog, through algebraic, through that minimizer equation, we can declare the function of decoder and
Exactly,
encoder.
exactly. That's what I'm trying to say. So, for example, what you do is in Verilog, you define the hardware. See, I'll tell you one thing. For example, if I say that you have an AND gate, okay? Let's say
Okay.
that if you have an AND gate, now the truth table is like 1 1 is 1, rest for everything it is 0, right?
Hmm.
Now you are not putting the truth table anywhere inside this AND gate, correct? Na?
Okay.
This is the characteristics of the AND gate, that when you put 1 1, the output is 1. And rest
Okay.
of the cases the output is 0. So when I'm
Okay.
saying that this truth table is represented by a AND gate, it does not
Hmm.
mean that I am putting the whole equations of this 1 1 1, 1 0 0, 0 1 0, and 0 0 0 inside the AND gate, correct?
Actually, it is a software written for the AND gate. Verilog is in a language which
Correct,
represent software representation of that logic, isn't it?
correct. Yes. So
But
so
where is that logic in the controller?
no, the controller is made of that logic. See, when you
Con-
say that, for example, in Verilog, let's say A equals to B and C, okay? You write this,
Okay.
right?
Okay.
You write this. Now, these are not instructions. The
They are not instructions.
what the Verilog compiler will do is the Verilog compiler will take this and translate into a AND gate.
AND gate.
Okay, so similarly, whatever you have, for example, if you say that if my instruction is equals to let's say 3e, then you fetch the data, for example. So this is something
Okay.
that you have written in Verilog. So it is not
Okay.
that they are going to put some instruction somewhere inside the controller. No, this is the controller. This Verilog compiler is going to convert this whole thing into a hardware,
Okay.
okay, which will automatically compare this with 3, or for example, it will automatically put a logic such that 3 gets decoded and 1 is generated here.
But it is full whole responsibilities of the compiler and assembler
This is, but see, the Verilog compiler is different from the C
from a
compiler.
controller, simpler or okay, C compiler in the microcontroller.
Right.
Okay.
Yeah.
But there is a compiler in the controller, or we have to
No, no,
compile
no.
and get decoder.
No. There is no compiler in the controller. What you do is you
There is
write,
only decoder.
yes, only decoder. But
Only
there are
decoder.
many other logics, not only decoder, but decoder is one of
Uh,
them. Yes,
Decoder is one of them. Okay.
correct.
Excuse me, sir.
Yeah.
Actually, I would like to add to this. Basically, he's asking is how is the microcontroller recognizing the instruction that we are giving, right?
Yes.
So
Yes.
yes. So actually, what the thing is, there is something called as opcodes. Every instruction, every combination of instruction that we have, there is a particular opcode for it, and that opcode is actually present in the memory itself. So when we give some instruction, the microcontroller sees that as an converts it into the machine language, and then it sees that opcode, and then it executes the program. It's like that.
So opcode is already in the controller.
Yes, it's actually present in the memory in the form of binary bits, but it's
By
actually inside the microcontroller.
okay.
And
And all
when
okay. But
we
all
write,
opcode is different from controller to controller.
yeah,
Yes.
it's every time it will be different because the family of processes are different, so the instruction set
Assembler.
will be different. So
But it
basically,
means that there is a separate space for the opcode in the microcontroller, isn't it?
yes. There is a space where all these instructions, combination of instructions that we write is already present in the microcontroller, and we call it as opcode. and these opcodes are present within certain location in the memory.
So opcode makes the sense.
Yes, that's how the instruction is decoded.
Okay.
Yeah, but see, I'll tell you, that is not necessary. What he's saying is, well, example, let's say you have an controller. Now you have this program memory where all the instructions are there, and then you have a small memory here which stores the opcodes that you are saying,
Yes,
right?
Yes, yes,
yes.
yes, yes.
It is not necessarily true. It is not necessarily true.
Assembler.
No, 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 no.
Basically, if we study the 8051 and 8085 microcontroller and processor, we will
Correct.
see that these opcodes are present in there.
No, no, the opcodes might be present, but the opcodes are not
Hmm.
present in the form of memory. Okay, see, I'll tell
Yeah,
you.
see, these opcodes are actually binary digits in the
Correct,
form of
correct,
instructions.
correct, correct.
Yes.
But when you say that opcodes are stored in memory, what it means is there is a memory inside the controller which sequentially stores the opcodes. But it is not like that. So, for example, let's say I have, let's say, one,
Hmm.
and then one here. I have connected to VCC, right? This is
Yes.
one. Let's say, okay. Now, for example, I have, let's say, three AND gates, okay, and then I have connected to OR gate, right?
Hmm.
Now I
Yes.
have connected VCC. Now connected VCC. Now I have taken these three lines out. Okay, and I
Hmm.
say
Hmm.
that if I give 1 1 1, if I give 1 1 1, my output is
Hmm.
1, correct?
Yes.
For
Okay.
example, if I say that, so it does not mean that I am storing 1 1 1 inside the controller, and the moment I am giving 1 1 1 as input, it is getting compared to this 1 1 1, and if these two comparisons are one, and
Hmm.
then the output is one, and this opcode is stored in memory. See, this opcode is what? This opcode is VCC, 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 right?
Hmm.
This opcode is VCC, VCC, VCC. No, VCC, VCC, VCC is not stored in memory anywhere. They are just part of the hardware. So we cannot say as such that yes, it is stored, definitely stored, but not in
Hmm.
sequential memory.
Yeah, yeah, it's like I understood
Sir,
that, but the code is actually in there. It's just the controller that is taking all these combinations and executing it, right?
Absolutely, absolutely,
Ah,
absolutely.
yes. Okay.
Both
Yes.
both should be looked in different ways. That is, one in hardware and other is firmware, isn't it?
Sorry, sorry.
sir,
One
assembler
in.
converts.
No,
Okay,
see,
carry
as
on.
yeah, who was speaking? I could not follow.
Both should be looked in different ways. That is, one in hardware and other in a firmware way, isn't it?
See, don't go into that firmware part. Okay, we will not talk about firmware right now because firmware is used in this terminology. Firmware has been used in many different ways. So for example, when I say firmware in ARM, and when I say firmware in Arduino, and let's say when I'm say firmware in some ASIC or SoC, they all mean something different. So we'll not talk about firmware here. So the only thing that we will talk about here is in this course is hardware, or as of now we'll talk only about hardware, this opcodes. Okay, now opcodes, as he mentioned, yes, it is stored in the controller, but it is not stored sequentially like the ways we store data in memory. And the other thing that we are going to talk about is machine instructions. Now, this machine instructions are
Hmm.
something which are generated from your C code, correct? The C code generates the machine instructions. Now, these machine instructions are compared with the opcodes, but these opcodes are not stored in memory anywhere. This is just a part of the hardware. And finally, it takes a call. So that is the way the whole hardware gets executed. Okay.
Okay.
So means one opcode means one instruction, right? If we have an instruction, say we write,
Yes.
we have to move some immediate data from one register
Correct.
into a
Correct.
register using the
Correct.
move instruction. So that
Yes.
one instruction is one opcode, right?
Absolutely. Yes.
Yeah.
Yes.
Okay.
Yes.
And that is then the controller executes that instruction.
Yes. The controller
Okay.
executes it. Yes.
Right. Okay.
Okay. Yeah. So this SAR question, I guess, is clear. So in between, someone I think asked me some question. I said that to wait because I was answering other questions. So anything?
Sir, again, that part is of practical on board, some STM microcontroller board. Okay.
Which one?
Hello.
Which one? Which one?
Uh, that that is going to come in next week 4 or something like that.
Maybe,
That
maybe,
on. So
maybe.
there are programs
Hmm.
to LED toggle the LED or
Hmm. Hmm.
external switch or like that.
Okay,
My
okay.
question is that
Hmm.
if we do embed.h file header file,
Hmm.
okay, and doing a single program,
Hmm.
can we run multiple programs at a time and pressing button, doing some LED toggling at some frequency, then next LED with some different frequency or like that?
No, for
Can
example,
we
yes, but you have to be.
can we do multiple works, multiple programs at a time in the
No,
controller?
no, 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 no. For example, actually, you can do, it is, for example, what you are asking is, let's say that you have one microcontroller, you have three LEDs, right? Let's say
Three
rare R,
LEDs.
G, B. Now you want to toggle this at 100 hertz, right? Let's say
One is
you
100 hertz, second is 50 hertz, or some another
correct
is 200 hertz or like
200.
that.
Yes, definitely you can do, definitely.
Yeah. Or I can run the motor at one time. I can run
Yeah,
the
yeah, you can run this motor. You can
okay,
run this motor.
4 5 works at a time.
You can
But
do
that
hundred of works at a time, but you have to make sure that the controller is running at that speed. See what?
okay.
Hmm, hmm.
How the time sharing is done? Or the program has to be shared like that because
No, no,
controller is executing one instruction at a time.
correct. But see, the point is when you are when you are saying that it is running at 100 hertz, or let's say I'll take it as 1 hertz, for example, for just for the sake
Okay.
of simplicity.
How?
Let's say
Okay.
so 1 second is on and 1 second is off, right?
Okay.
Now for that, what the controller has to do, controller at this point of time has to give one here,
Okay.
Now one, since one has been given in this port, controller can do the rest of the jobs. The one will still remain here.
Okay.
Okay. Now in this part of the time, which is let's say most of the time of 1 second, controller can do different job, right?
Okay.
And then after 1 second, after let's say the time 1 second has elapsed, the controller can
Hmm.
come and make it zero.
Okay.
Correct. So this is the way.
But
Well, it
Hmm.
depends on the clock frequency,
Yeah.
no, sir.
So clock frequency, for example, let's say it is right now, let's say at 10 kilohertz, the clock frequency of ARM, for example, let's say.
example, okay.
Okay. So if you're, that's what I'm saying. If your controller frequency is fast enough, you can do multiple
Then,
jobs.
okay, but the infinite loop is working for one particular job. Second infinite
No,
loop is working
no, no,
for
no, no,
another
no, no.
job.
There is no second infinite loop. Okay. See, there are 3 infinite loops only when you work on RTOS environment. If you are not
Uh-huh.
working on RTOS environment, there are no 2 3 infinite loops. There is only one
One loop,
infinite loop. Yes,
one mat
this is
loop.
while let's say this
Okay,
is
okay,
while one.
okay.
Okay, here you, let's say you
Uh,
toggle the LED R, you toggle
hmm,
LED G, you toggle LED
hmm,
P. Here you put motor. Now everything is
hmm.
happening very fast, right?
In
Now
a single loop. Okay, okay.
correct, correct. This is all single loop. This is all in while one.
वाइल वन,
Yes.
मुझे वैसा ही करना है कि जैसे पहला का इंस्ट्रक्शन दे दिया, दूसरे को भी चालू करो,
Hmm.
तीसरे को चालू करो एंड क्लोज देम sequentially
Yeah, yeah. Same
with
thing.
some
Correct,
okay,
correct. Same
but
thing.
in single infinite loop.
Yeah, there has to be only one single, because see, the moment you put one infinite loop here, you cannot put another infinite loop here, because the instructions will never come out of this loop, right?
Oh, never. Okay, okay,
Okay, so it cannot come here unless and until you are running on a RTOS environment. So we'll not talk about that
okay.
RTOS environment. We'll not talk about that.
uh,
So
okay.
because right, this course I don't think RTOS is covered. So we'll stick to a single processor environment
Single
and
program.
bare metal environment. So here what you do
Mm,
is, let's say you write one program. Uh, let's say you write one program while one. Okay,
mm,
you put set R equals to 1. Okay, set
uh-huh,
G equals to 1.
mm,
1. Set
mm,
B equals to 1.
mm,
Okay, you put it. Let's say you want to toggle RGB. Okay, for
mm,
example.
mm,
Now you wait here. Wait here
mm,
for, let's say, 990 millisecond, for example. Okay.
mm, mm.
Now,
Yes.
since now, but the next time you come to the loop, you know that which state you have set it last time, right?
Okay.
So
Fine.
you just toggle the state.
Mm.
So what will happen is all your LEDs, for example RGB, all your LEDs will work at, for example, for some time it will be 1, for some time it will be 0, for some time it will be 1, for some time it will be 0,
But
because tell me.
their starting point is unique for all. Okay, because you have started at one time. Okay, all clock will start at the first, but the ending and the period is different.
Correct.
That
I
can be
mean,
set.
yeah, that can be set. That can be definitely set.
Okay. No, because starting point will be the same
Yeah. Starting
because it
point is
is
definitely
while
same. Yes. But for
same.
example, let's say you can always put, you start your G with 0 and then you toggle it.
Okay. Hmm.
Okay. You can
Okay.
start
Okay.
like that. That's up to you.
Hmm. Okay.
Yeah.
Okay.
Okay. Any other
Okay.
question on DA converters?
Yes, sir.
Sorry.
Sir, I have one question, sir.
Yeah. Tell me.
Sir, within the clock period, it's within the clock frequency, the clock frequency with clock frequency that clock pulses will be generated. No, that within that pulse, that instructions are is going to be executed, right, sir?
Yeah. Right. So what you mean to say is like this, right?
Yes, sir.
Hmm. Like this, you are saying in this pulse, in this pulse, in this pulse, provided that
Mm.
your instructions are executed one T cycle.
Yes, yes, sir,
Hmm.
exactly.
Hmm. Hmm.
If it is not executed within the cycle, we should need to mention a delay now, sir.
Actually, see, can you give an example of what you're trying to say? I understood your question, but there are two facets to the answer, okay? Whatever you're saying.
Yes,
So,
sir.
for
For
example,
example, one cycle will take 2 milliseconds, but it is executing 2.3 milliseconds. If it is taking 3.3 seconds more,
hmm, hmm. Then you
if you
put a
put in
delay
a,
state. Then you put one T cycle delay.
yeah, after the delay, it will be executed normally, no, sir.
Correct, correct. Absolutely, absolutely.
Even it is applicable in this controller also, no, sir.
Absolutely, absolutely.
Yeah, sure. That's it, sir. Thank you, sir.
Okay, okay, okay. Anything?
So today, are we going to discuss assignment?
See, I am not supposed to discuss the assignments that are currently there in your, which you are, you know, going to submit. Okay, so I cannot discuss those assignments because I have been discussing those assignments. Then I got a mail from NPTEL that you are not supposed to discuss those assignments, but you can discuss some other assignments. Okay, so this is what. So I would like to say, wait. So what I can do is,
Sir,
yeah,
shall we ask the doubt from week 2 assignment, sir?
okay, you can ask.
In week 2,
Just hold on,
question
just hold
6.
on, just hold on. Hello?
Hello,
Yeah,
sir.
yeah, you can ask me.
Uh, Sir, in week 2, question 6, option D, what type of addressing mode, sir?
Mm, I don't have those questions right now. So since you have already submitted the assignment, can you just send me one
Uh,
email? Just send me one email.
oh, okay, sir. For which email ID?
Yeah, okay, I'll give you.
Uh,
It's KUNDU.AH.
KU.
KUNDU
B.
at
Kundu.
PANHIMITRA.
Banki Mitra.
Yes, yes, right.
Banki Mitra. @gmail.com.
Correct.
Okay.
So
Thank
yeah,
you.
so maybe we can discuss all these questions. So yeah, you can try to answer the first one.
Consider 12-bit DSC.
10 by 2 to the power 12 minus 1.
Correct. Okay. So any questions in that? This was pretty simple. And anyone has any doubts?
2.44 millivolt.
Yeah, I mean, but was your equation 10 by 2 to the power 12 minus 1? Ah, correct. Then
2.44 millivolt.
ठीक है.
Option B, sir.
Okay.
Can you discuss question number 2?
Yeah, I mean, just give it a try. Maybe 10-15 seconds. I'll discuss.
Question 4-bit weighted.
Yeah, anyone?
10 kilo ohm and 16 kilo ohms. 10 and 80 kilo ohm. 10
Correct.
kilo ohm and 80 kilo ohm.
Correct, correct.
Am I right, sir?
Yes, yes, you are right.
Thank you, sir.
Yeah, so any question? Why?
Sir, actually it is
Maximum
asked
current
D3 and
current will
D.
count.
Sorry, sorry.
Resistor connected to D3 is R, sir. Here given as 2R is 20
Actually,
kilo
the
ohm.
answer is none
Means
of
the
this,
resistor
sir.
connected to D2 is
Why?
2R.
Just hold on. If the resistance connect to अच्छा उल्टा दिया है. No, wait. D3 connected to most of the 6. 0, 10, 20, 40. Oh, they have given opposite, huh?
Yes, sir.
D3.
Resistance connected to D2 is given is 20 kilo ohm.
Correct, correct.
So in a 4-bit ADC, 2R resistor connected to D2. So the given one is 2R. From that R is 10 kilo ohm. So they are asking about D3 and D0.
I
The
understand.
resistor connected to D3 is R and D0 is 8R. So we'll get a 10 kilo ohm and 80 kilo ohm.
Just hold on. D2 is 20, right? So first is your R, then 2R, then 4R, then 8R. This is the way it is connected, right? Then now it is said that D3 is the most significant bit.
Most
This is D3.
significant bit.
So this
R.
is D2, this is D1, this is D0, right?
Sir,
D0.
no, sir, in that slide,
D, yeah.
most significant bit, lower resistance connected, sir. Here,
D3 R.
D3 is the most
R.
significant bit, is connected
Yes,
with
yes,
the R,
D3.
sir.
D3 is
D3
R
R.
and yes,
R.
D2,
D2,
D1,
D1,
D2,
D0.
D1, D0.
yeah. So I guess this is the one, right?
Yes, sir, first option, sir, 10 kilo ohm and 80 kilo
10.
ohm.
Yeah. Someone had any doubt, no, on this one?
It is clear, sir. Thank you, sir.
Okay. Next. this resistive ladder type, so it's okay, right? Resistive ladder, you want to discuss?
8-bit.
Question 3, yes.
Not 12.
Sir, sorry for interrupt, sir. Can you please solve this question number 2, sir?
Okay, so what it says, see, normally, wait, so you have this connection, right? Yeah, so you have this, for example, you have this V0, V1, V2, and V3. They are all connected via resistors, right? Let's say this, and they have this, for example. They have connected via this. Now what it says, like D3, which is, for example, the V3, that is connected to, you have this 10, right? Then 20, then 40, then 80. Okay. The reason for that is, for example, when you calculate the whole thing and you make 0, what you get? V3 by 10, okay, plus V2 by 20 plus, why it is not, V1 by 40 plus V0 by 80, correct? All these things multiplied by your RF and combination of this, so some constant K. Now this is your V0. So if you take 80 common, for example, okay, so what you will get here, if you take 80 common, then what you will get here is 8, and then you will get here 4, then 2, then 1. So this is the same thing as, if V3 is your most significant bit, this is connected by 2 to the power 3. If V2 is your most significant bit, then it is connected by 2 to the power 2. Sorry.
Okay, okay, sir. Please, clear.
Yeah. Yeah. So any questions on this one? This is
A,
art,
7
art.
and 9.
A option, sir.
Yeah,
7 and
A,
9.
right,
7
right.
and
Very
9.
nice.
Yeah.
Yes.
So what it, no, let me see first. Okay.
Question 4.
So you have R12 ladder, right? You have 2R, R. Now this combination is there for 1, 2, 3. Now since you have 8, so that's why you have around total 16, 16 combination. Okay, fine. 7 and 9. Okay. Now tell me question
Flash
4.
C.
This is
Flash
analog
type.
to
Flash
digital.
type.
Yes,
Flash
Yes.
type.
correct, correct,
Flash, flash.
correct.
Sir, I have one doubt, sir.
Yeah, tell me.
Excuse. Sir,
Yeah.
comparing counter type and successive approximation type, which one is the low speed converter, sir?
Uh,
Since the
Comparative,
counter type, it gives a 2 power in steps
correct. Successive
to
accumulation is
complete
faster.
one conversion.
Yeah.
It's only N type. Am I right, sir?
Yes.
Successive approximation faster compared to counter type.
Yes, yes, yes. See, but you cannot
But
say like,
counter and tracking type both are in same speed as well.
yeah,
Counter type and
yes,
tracking
counter
type.
and tracking type both are same speed, but there is a difference. The difference is, for example, let's say
Okay.
when you, let's say for the counter type, every time it is done with the conversion, it resets itself to 0, right? So for example, if you have
Yes,
an
sir. Yes,
analog
sir.
input like this and this, what it will do, the counter type will come to
Okay.
0 here, and it will again start counting from here
Yes,
to
sir.
here, right? But if you see
Yes,
this
yes, sir.
yeah, tracking type will not do that. Tracking type will go here, tracking type
Simply
will
increment,
come,
decrement,
yeah,
isn't
come
it?
here, and then it will come here. Okay, now this time
Okay.
might be less than this time.
Okay.
Okay. Yeah.
Thank you, sir.
Yeah. And someone asked me about whether which one is fastest, flash type or success approximation type. But you should never compare like that. I mean, just on the basis of one. See, it can happen that for one specific analog signal, your counter type is giving the output in one cycle, and your successive approximation type is also giving the type in one cycle. Okay, so you take the worst case. You take the worst. So whenever you discuss about this analog to digital converter, you say that for the worst case input, who is having the fastest conversion speed. Okay.
Okay. So here the fastest is flash type and counter type is slowest.
Counter type is the slowest. Yes. Yeah. Okay. So next, band limited signal. Tell me.
Sir, previously
Sorry. Sorry.
in counter type, sir,
Yeah.
you draw the diagram of
Which one? Which one?
for the fourth, comparing the successive, counter type and tracking type.
Yeah.
Sir, I have a question, sir, while looking at that. Sir,
Yeah.
in a counter type, the step size will increment, no, sir, for every bit.
The step size will.
Increment, no, sir, step size.
Right. 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 Right.
Yeah, in a tracking type, it is a continuous process. There will be no any sample hood or nothing that we don't equalize that value.
No.
It
No.
is
No.
a
No.
continuous.
No. Sample and hold is always there. Sample and hold is
Okay.
always there. Okay. Without sample and
So
hold,
can you
nothing.
please differentiate that two differences, sir? That is my question, sir. That's
This
it.
counter and tracking type.
Yes, sir.
Yeah. So in counter
How
type,
it
what
would be
happens?
different?
Yeah. So in counter type, what happens is, let's say you have given a voltage of 8 and then you have given a voltage of 7. Okay. So wait. So let's say that you have given a V input of 8 volts and then you have suddenly changed it to 7 volts. Correct? Okay. Now what it does is, now this counter type, what it will do is it will start counting from here. Okay. It will start counting from here. It will go. Okay. And it will say here that yes, my output is 8 volts. Okay. Now after this conversion is done, what it will do is it will come back to 0. And then again, when you start the conversion, it will start from here and it will say, okay, let me see. Okay, fine. The output here is 7 volts. But in tracking type, what happens is, in
Every time
tracking,
it will start from my initial point onwards, sir.
sorry,
From zero, it will start, sir, for counter
always
type.
from 0.
Every
Yes,
time.
yes, yes.
Sir, that rise is okay. Even fall also, it will be happen instantly, sir.
No,
There
this
will be
fall is
some
resetting, right? This fall means resetting to 0.
yeah, resetting it will take some time, no, sir. It
No,
won't
no, no.
happen
Resetting.
immediately,
No,
right?
no, no, no. See, this counter is counting is based on the clock, right? Let's say here and
Yes,
here
sir.
the counter is. But when you reset, it is an asynchronous reset. Asynchronous reset means it will happen almost instantly. It will be in very less picoseconds maybe.
Okay.
Okay.
Yes, sir. Clear.
Yeah. So
Sir, in
in
tracking type, it won't come to initial point, not zero. It will
correct.
come
So
to
it
some
will, let's
threshold
say it
value,
will,
right?
yeah, correct. It will track here and then let's say it will hold here. The moment it goes to 7, it will come down. So the time taken from going from 8 to 7 is very less, right? In tracking type.
Yes, sir.
And from here, you see this much
Sir,
time
is
it
there
has
any
taken.
difference formula, sir? How to calculate that difference? How much time difference between tracking type and counter type, sir?
Yeah, that depends on what
Time
kind of
save.
that kinds of input, what kind of input that you're giving. For example, let's
For
say,
example, if it is 7, no, sir. Here we are decrementing. We are going down, fall. If
correct.
it is
So,
rising, no, the
hmm,
same thing will happen, sir.
rising means,
If it
for
is
example, when you're rising from 0, let's
hmm.
say that you have given,
No,
let's
sir.
say,
In 8 volts itself, if we here in this point, we are going to 7 volts, right? Here
correct,
we are falling. If it is happening to 9 volts, if it is rising also, again from this point onwards, it is rising, right? At the time also, the same thing will happen.
right, from 9 volt, this one.
No, sir. After you take 7 volts, no, sir. Here,
right?
If instead of 7 volts, if you take 9 volts, the same
Yeah.
thing, the same procedure will going to happen. No, the
Yes,
time
yes,
will
yes.
also
For
reduce.
example, when you are continuously increasing, then in that case, there is not much difference between a counter type and a tracking type. It is
Okay.
only when you increase and decrease. For example, let's say when you have your analog signal which is noisy, it is continuously increasing and decreasing, right? It is not only increasing.
Yes, sir.
So that's why when you take some example, you always take like this, that first the voltage is increasing, then maybe you can take that yes, the voltage has increased here, then you take the voltage has decreased here. So when you consider both this rising and when you take both the increment and the decrement, at that time the speed comes into account for the tracking type and for the counter type.
Yes, sir. I understand, sir.
Hmm, hmm.
My question is, for counter type, for tracking type, it will take less time, no, sir. For counter type, it will take more time.
Absolutely.
Is there any formula to define how much time, how fast it is tracking type is?
Yeah,
In a theory,
yeah,
in the
yeah,
side
yeah,
sense,
yeah. No, it is. I mean, you can also always calculate the formula. So, for example, if you let's say it is V in, right? You are given V
yes,
in,
sir.
right? So the number of
Hmm.
cycles. So, for example, from 0 to V in, let's say the count is so V in minus 0 into TCK, right? This is your clock frequency.
Yes, yes, sir.
So this is your time to go from 0 to V in, right?
Yes, sir.
Now it depends on what is the next step is. For example, if this is V in by 2, let's
Okay.
say that you are coming here and saying that it is V in by 2, okay? Then how much time will it take from V in to go to V in by 2? It is V in by 2 into T clock, right?
Okay. It's dependent on the voltage rate, sir.
Absolutely, yes.
Okay, that voltage difference will define the time, right?
Absolutely, yes.
Yes, understand, sir. Thank you. Thank
Okay,
you.
okay. Yeah. Question 5. Hello.
Option D,
Greater than
greater than
25.
Why do you say option D?
Option C.
सर एफ मैक्स का इक्वल
greater
2
than
होता
2f
है,
max.
2f
Correct,
मैक्स होता है.
correct, correct, correct.
So 50. Option B. 50.
No, B is definitely, it is only 2F, right? When Fs is equals to 2F, then you get 50.
What?
Now there is a problem. What is the problem? Now people say that let's say you have a sine wave, okay, and you sample at this point, this point, this point, still you get a triangular wave, no? Still you get a triangular wave. But let's say that if you sample at this point, at this point, at this point, which is also at 2F, then what you get? You get continuously 0. So that's why 2F is not the correct uh, value with which you should sample. It should be always greater than 50 kilohertz
Max.
or greater than 2F. ठीक है?
Greater than 2F.
Correct. So why do we need a sample and hold circuit?
To maintain the
Option A, sir.
To
input
ensure
does not
the
change.
input
Input should not.
way to convert do not
Correct.
change during conversion. A
Correct.
option, sir.
Correct.
Option A.
Correct. What is question 7?
It's 1 by 2 की power n minus 1 into 100.
Sir, 8 by 1024,
8 by 2 to the power
8 by
10 minus 1.
2 per 10.
Correct. So it
Minus
is
1.
In
8 by
ADC,
1023, right?
it's a, yes, sir, 102.
1023.
Hmm.
Actually, in
To 4
DAC
no?
only full scale voltage divided by 2 power n minus 1, sir.
In
But for a ADC, it's given as simply full scale voltage by 2 power n.
No, it is everywhere. It is the same thing. Sometimes what
Same
happens
thing
is,
only, sir.
sometimes it
Ah,
happens is 2 to the power 10 is n is so high that you can ignore the minus
okay,
one term. That's all.
okay.
Sorry. So question 7, question 8. Just hold on, I'll come. You can tell me the answer. Just think.
Sir, can you hear me, sir?
Sorry.
63.
Okay. And
We need priority encoder with 63 inputs.
okay. But it says that which of the following is or are true.
Oh, C is all
Sir,
of it.
option B.
Hmm?
B and C, sir. B answer होगा.
Correct. B and C.
B and C both are correct.
Correct. Okay. Okay. So next.
Well,
Very important, huh?
8-bit counter type 6 maximum.
2 for 8, sir.
12. N.
2 raised to 8 minus 1.
Correct. 2 raised to 8 minus 1.
255.
Right. Okay.
It was 2 for 8 minus 1.
Tell me this one.
12 bit DC.
12.
12.
12, sir.
Right.
12.
Why do you say 12?
N, sir. N number of
It's
clock
n steps,
cycles
sir.
or
And N is what?
N. Number of bits.
Correct. ठीक है. So I guess you're good to go. Maybe you can start working on the.
Sir.
Sir, I have a question, sir. Sorry for
Sir,
interrupting, sir.
Can you
yeah,
repeat
please.
question
Question
number
number
10?
10. Yes, sir.
Question number?
Sir, please repeat question number 10.
Okay, so what it says is, for example,
10.
Yeah. So you're able to hear me, right? There is no lag.
Sir, solve the by using formulas.
This does not require any formula, no?
Yes, sir.
Does it require any formula? It's very straightforward, no? Why do you say it requires formula?
Sir, I think to the power n minus 1.
No. Why? Just go to your first note of this SAR. Just go to the notes of SAR. It's very important.
Sir, in question number 9, it's 2 raised to n or 2 raised to n minus 1?
2 raised to n minus 1.
I am also have same doubt, sir.
Which one?
Because in the notes, I think it's given 2 raised to n only.
The notes they have represented as 2 for n, sir.
No, it is 2 raised to n minus 1 actually.
Question number 9. Yes.
Yeah. See, because you are starting from 0, right? You are going up to 255. So
that is the worst case 2 power n, sir.
I understand. That's why it says that the maximum number of clock cycles. That is the worst case. Correct. So what it says is, for example, that when you go to 2 to the, let's say when you go to 1, you need 1 clock cycle, right? So when you go to 255, you need 250 clock cycle. Because 0 is always counted. 0 is the starting point, right? You don't need to count 0. Correct, na?
Yes, sir.
Yeah.
What's the answer, sir? 2 power n or 2 power n minus 1?
2 to the power n minus 1. But again, I'll tell you one thing. See what happens normally when the n is very large, no? People don't
2 to the
consider
power
minus 1. Sorry?
n or 2 power n minus 1?
2 to the power n minus 1. Are you not able to hear me? Hello?
Audible, sir.
Acha,
So
okay.
what is the final answer,
Yes,
sir?
sir.
Is
2
the
to the
2
power
power
n
8
All right, sir.
minus 1.
2 to the power n minus 1.
2 power n
Minus 1. Okay. So someone asked me the question like what happens to 12 bit, right? Why it is 12? Answer is 12. Right? Someone asked me this question?
Yes.
Yeah.
Yes, sir.
See what happens, for example, when how you are actually doing this successive approximation. You take something in the middle, right? You take something in the middle.
Okay.
Then you go bit by bit. Then you go bit by bit. So for example, let's say you have to consider and how do you actually increment the bit? You start with 1 0 0 0 0 0 0 0. Okay. So this is your initial value. Okay. Now this is of 8 bit, but what is your output? This is 12 bit. So you have to append these two. Okay. This is 8 0 0 4. Now what
So one
happens?
cycle for 1 bit.
Correct. Yes, yes, yes. One cycle for 1 bit. Yes. Correct.
Sir, sir,
Yeah.
sir, I have a doubt in theory part, sir. Sound segment LED display.
Okay. Oh, in which
Sir,
one? Acha, in the slides?
in, no, sir. Theory, sir. In theory. Theory, sir.
Question 3.
Not questions, sir. Theory. Slides, sir. Slides.
Oh, acha, slides. Yeah, that's what I'm saying. Slides. Yeah.
Yes.
Yeah, tell me. Yeah.
In sound segments display, the sir has been explained about common node and common cathode, sir. There
Yeah.
will be connection difference, right?
Right.
Sir, in connection through hardware, it is connection difference. Is there any difference in
Software.
operation and all or nothing?
Yes. No,
Anything
no,
else, sir?
no. See, it is what output you drive. Okay. That
Hmm.
creates the
Sir, I
difference.
have one
For
more question also, sir. Before that, sorry for interrupting.
hmm.
Sir, in sound segment display, in for B and D, we use lowercase, no, sir?
B and D we use lowercase. Yes.
Yes, sir. Why can't we use for uppercase, sir?
No,
B is
because
possible, no, sir.
no, because it conforms to 8, na. For example, when you write B like this,
Okay.
you do not know whether this is 8 or B.
For D, it is possible, no, sir.
Yeah, D it is possible, but to maintain the commonality, because you cannot
Oh,
have only B capital letter or D capital letter and rest everything small letter. You cannot have that.
okay.
Okay, just to have a
Sir,
commonality.
okay, there is no difference between common node and common cathode
But
connection.
no, but see, D also is a problem, no? How will you write D like this, right?
Yes, sir.
If this is 0 or D, you can write
Acha, acha.
E. That is okay. But D and B both are problems, no?
Okay. Sir,
0.
sir,
Hmm?
for LCD, sir has been explained about the code also a little bit.
Hmm.
Sir, for a sound segment display also, is there any specifications sir, to implement before that we need to know?
No,
Like
no,
that.
no, no. There are no spare. See, what you do is you see
Direct
all these
connection,
8
sir.
pins, right? No, acha,
Yes,
before
sir.
that I will answer that common cathode and common anode wala. See, in common
Okay, sir.
cathode, what you do is you put this 0 0 0 0 0, and common anode you put 1 1 1 1. For example, you have to light all the LEDs. Okay, so in order to excite, you have to give 1,
Okay.
and for the other one, you have to give 0. Then it will get excited. So it
Hmm.
is what number, what bits you drive. What I mean, the value with which you drive the bits that decides the intensity, whether the intensity
Okay.
is positive or 0.
Yes, sir. What and all we are going to connect for a common node, we should need to connect that one as a VCC. Rest of them are ground, right?
Correct, correct.
For cathode, it is vice
Opposite.
versa. If it is ground, it is VCC. If it is VCC, it is ground.
Right, 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 right.
Sir, for hardware, it is okay. For is there any difference or any technical differences?
No technical, there are no, I mean, technical differences are then from the hardware point of view. From the software point of view, there are no technical differences. You just
Sir,
give
for
the values
hardware
for
also, I get a little bit doubt, sir.
tell me.
Sir, generally diode will operate in forward bias only, no?
Correct, correct.
that if it is reverse, it is not going to happen in a reverse bias, right? It is just connected in anode and cathode terminals to take the
No, no,
output.
not
There
like,
is
no. I got it. Not like that. See, let's say that you have one diode, right? You have a diode
yes,
like
sir.
this. For
Yes, sir.
example, if I say that I have connected this to 5 volt,
Okay.
okay, then you can drive here 10 volts and the diode will get turned on, correct?
Yes, sir. Yes, sir. Exactly.
So for example, if I say this is 0 volts, then you have to drive it with 5 volt, correct?
Yes, sir.
But it is the other way around. For example, if I connect this to the power supply, 5 volt, I am connecting this to the power supply, correct?
Hmm.
This part. Then what, with what value I have to drive it here to make it on?
Till 4 it will
Ground,
be
ground, 0 volt, ground.
Correct, correct. Yeah, tell me, you have any questions?
no, sir. I have small question, sir. After explaining it, sir, here you consider it as VCC, no, sir.
Hmm.
In the in other terminal, you will connect it as 0. Even till 4 point, if there is voltage difference, there will be current flow,
Absolutely.
no, sir.
Let's say this is not 5 volt. Let's say this is 4.7 volt. Okay.
Yeah, yeah.
Hmm.
So my question is, if it is connected to anode like the cathode, no, if it cathode operation will get changed, no, sir.
No, but it is how you are differentiating. See, the point is when you are saying that it is a common cathode and common anode, then you are also changing the supply, right? You are changing this supply to ground, right?
Okay.
So, for example, let's say I'll tell you that you connect this, you put the power supply here, VC, right?
Hmm.
You put the power supply here. Then you have to drive here with 0 to glow the LED, correct?
Yes, sir.
But for example, if I just do the opposite thing, I just do the opposite thing. So I connect here VCC and
Okay.
say that what you have to drive here with. I connect here 0. I connect here to ground. And I say what I have to drive here with. I have to drive with VCC, right?
Yes, sir.
To make that. So for the same hardware, the way you are connecting your diode decides whether you are going to push VCC or ground to make it glow, right?
No, sir. We are taking the reading through cathode and cathode. That diode will be in forward bias in both cases, right, sir?
In both the cases, yes.
It won't be operated in reverse bias, right?
No,
Reverse
never,
bias,
never, ever,
it is going to be off the
never.
That's my question, sir. I
Okay,
get little bit confused over there. We are
okay.
just taking the readings through anode terminal and cathode terminal. That we are not going reverse bias, right?
No,
I
never,
thought, yes.
never.
Never reverse bias, it would be off norms. Little bit confused. That's it.
Absolutely,
Thank you, sir.
yes. So, anything else?
So in question number 10, SAR is started with 100 something binary.
Hmm.
If it is different, means it is started with another binary number, then what will be the change in the answer?
Which one? This one?
In question number 10, sir. Question
Hmm.
number 10.
Hmm. Then you cannot say that the number of clock cycles to carry out one conversion, because then it will depend one. If you see this, for example, if I tell you that this is the slide, let's say this is the slide, right? This slide. So you are not
Yes.
starting. Yeah. So you are not starting from here. Sorry. 3. So it says, sorry, it says you are not starting from here. Let's say you are starting from here, 0100, right? So you cannot have this symmetricity. The symmetricity that you have here, you cannot have that. So for example, if I replace this with 0100, then one length will be longer and one length will be shorter, right?
Yes.
So then, for example, if you don't connect it to the middle, if you connect it to one of the sides, for example, instead of 1000, you connect it to 0100, then what is the difference? This is 4, right? This 4 will get added to 12.
Yes.
Okay. So this 4 will get added to 12 because that is the number of extra cycles it has to do. Sorry, not 4, it is 1. one will get. For example, if you start from here and you try to go here, 1 1 1 1, how will it go? It will go from here to here, then here. I'll change the color. It will go from here to here, then here to here, then here, here, here. If you see the number of paths, it is 5. It is not 4. But if you start from the middle, then yes, it will take 1 2 3 4. Only 4, because you have 4 bits. But the moment you try to be a bit asymmetric, or you try to start from one of the end, for example, if you start from 0010, then the number of clock cycles it will take is this. So you have already 4 plus this 2. 4 plus 2, 6. So this
Okay.
is this is how it will go.
Okay. Thank you, sir.
Yeah.
Sir, week 3, slide number 5, sir.
Slide number 5 I don't have. Can you tell me the topic?
Yes, sir. Resolution or step size.
This one?
Yes, sir.
Tell me.
Sir, in this, no, not this one, sir. Another one. 5 numbers, sir. Resolution or step size. It will be above, sir.
Okay. Yeah. But this is 5, no? This is not 5.
No, sir. Resolution or step size. Very.
But why don't I have that?
Go down, sir.
After flash type or where?
Wait a second, sir. Yes, sir. After. Wait, sir. Sample hole. Resolution.
Yeah, did you get it?
Wait, sir. I'll just. Wasn't underneath. Let's type edition. It is showing 5 number page, sir.
No, this one, resolution of step size. Yes. Okay.
Yes, sir. In this case, V reference is equal to full scale voltage. Here, step size or resolution is depending on the V reference voltage. The percentage of resolution is totally depends on the number of the bits.
Percentage resolution totally depends on number
of the bits.
This is
But
percentage
as per the
resolution, right?
resolution, yes, sir.
This is
Yes, sir.
percentage
As per
resolution.
the resolution, it says that what is the minimum input voltage will be applied so that the output will change. Correct, sir.
Correct.
Yeah, but as we say that in percentage resolution, we have
No,
seen the delta.
I think resolution is how much the output voltage will change, no? Or how has he defined it? Wait, I think it is like see, smallest step that occur in V out. So how much the output voltage will change? It is not how
As
much
a
the
result in the change in input D.
correct, as a result in change in input D. So whatever
Input D,
D
how
has
much?
changed, yeah. So the smallest
Yes, sir.
change in the output, that is
Input.
called as resolution. Okay, smallest change
But
in
sir,
the
here in resolution, as we do that V reference by V reference, it means it is totally cancel out and it totally depend on the number of the bits.
no, it is percentage resolution. This is not resolution. This is percentage resolution.
Yes, sir. In percentage resolution, it is totally 1 by 2 to the power n minus 1.
Yes.
Here, V reference and full scale voltage are both are same.
V reference, full scale voltage, both are same. Yes. People are joining now. Achha.
So once repeat once, both sir. Step size resolution.
No, see, the step size is, for example, let's say this is your V in, okay, and this is your V out. So V in is changing by some amount. So what is this? For example, let's say this minimum amount is D, for which there is a step change, correct?
Okay, correct.
Okay. Now this step change is called the resolution.
Okay.
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 So
It means what should be the change in the inputs so that there will be the smallest change in the output.
correct. Yes, yes.
Sir, actually, I have a doubt that what's the unit of step size? It's a volt or millivolt, sir?
No, that depends on, for example, what is the value of this, because volt and millivolt are both same metric, no? It is just a power of 10 to the power minus 3. See, you can say that volt and ampere are two different units, but volt and millivolt are not two different units because they are scalable with each other.
Okay, sir.
Okay.
Sir,
Yeah, tell me.
sir, in LM35,
Hmm.
sir, in LM35, through lecture, I got one transistor. One transistor width is 10 times more than the other transistor.
Correct.
Sir, I didn't understand if a transistor is more, that current flow will be more, sir.
Correct. Yes.
Okay, sir. I didn't got they didn't mention, sir, which transistor is more, because if it is connected to op amp, no, that if it is connected to in non-inverting and inverting terminal, with that also it will change, sir. Which transistor is has more
The one which is
width?
having 10E. You have something, no? 10 which is having 10 width.
Yes, sir. That one Q1 or Q2, sir.
Q1.
Okay, sir. Can you speak about little bit about one thing, sir? Yeah, 1 minute, sir.
Hmm.
Mechanical relay and solid state relay, sir. I didn't understand a little bit. Can
Yeah,
you speak about
mechanical
that,
relay
please?
are electromagnetic relays. Okay. So mechanical relay is like you have, for example, let's say, wait. So mechanical relay, it is like, okay, you have one pole here, and this is, let's say, an electromagnetic. So you have one coil here. The moment you pass current through this coil, this gets activated, and the connection is established. So whatever
Sir,
current is there.
through magnetic flux, it is going to activate, right, sir?
Correct.
That's my doubt, sir. I hear through there is no any contact between them, no. How it is going to get through magnetic flux linkage only, it's going to activate.
Correct. Right.
Yes, okay, sir. Yes, continue, sir.
Okay. No, yeah. This is for electromagnetic, and for MOSFETs. I mean, for example, SSD relays or the solid state relays. What happens is there is a MOSFET or is a transistor. So the moment you turn on the transistor, this input comes here. So there is no air gap. Okay. So there is no isolation. Here there is
Okay,
some
okay,
in electromagnetic relays there are some isolation, but in SSD there is no isolation. Okay.
okay. Sir, this makes the difference, no, sir. Hardware and SSD recently came. That this is the principal difference, no, sir.
No. The whatever. For example, see, the hardware SSD means your solid state drive.
Yes, sir.
See, solid state drive is different, and your relays are different. Okay,
Okay.
solid state
Sir,
drive is
in
different
between,
because that is memory.
sorry,
This is a relay.
sir, one person asked about one question, no, sir. It is out of the box.
Hmm.
You spoke, no,
Which one?
initially relays something about at opcode they you said about one concept, no, sir.
Correct.
At opcode,
Yeah,
at
right,
initially.
right.
Can you speak about little bit more, sir? I will get I will search about it.
Okay, no, see what he was saying is, okay, for example, the moment you give the instruction in memory, how the
Hmm.
controller understands that these are the instructions. There are some valid instructions, so how the controller understands that. So the how the controller understands that it takes the opcode from the memory. Okay, it takes the opcode from the memory, and then here there are some already hard coded opcodes. They are not stored in some memory. They are hard coded opcodes. Now this opcode which is fetched from the memory is compared to the hard coded opcodes, and then the decision is taken. That's all.
Okay, okay. It will establish the connection now, sir.
Correct. It will no, I mean not establish the connection. What
Hmm.
there are no relays in between. It will just pass. So for example, you can say there are many MOSFETs here. Okay. So there are many
Okay.
AND gates, NOT gates. Okay, all those things. So let's say when you talk about the controller, you don't talk about relays. Okay. So there are
Yeah.
some, you can say there are some small switches. So you say they are switches, not relays.
Okay. No, sir. In through coding also through switch level modeling, we can establish the which has to perform through Verilog only. In gate level modeling, you will mention
Yeah, yeah,
how to.
absolutely you can do, but the whole point of having a programming language is that you don't have to go to gate level modeling. You go to gate level modeling only when, for example, there is a hardcore requirement, then only you go, or else you stick to normal software modeling, or we say it behavioral modeling.
Yes, sir. Actually, the professor video I thought I see the YouTube list, sir.
Hmm,
He
hmm,
spoke about Verilog also,
hmm.
Verilog and physical design
Yeah, yeah,
as well.
yeah. Indranil sir also speaks about that.
Yes, sir. Is there any courses, sir, particularly about professor? Is there any courses, sir, rather than physical design, embedded system? Any other courses are available, sir? If time
No, I
passes, I
don't
will.
think Indranil sir teaches only Verilog and embedded, sir. Embedded. Only these two.
And ethical hacking. That's it, sir.
No, I am not aware of ethical hacking.
Okay, okay, sir. Yeah. In YouTube, I search about it. So that's it. Thank you, sir. Thank you.
Yeah,
Sir,
yeah,
sir, page number 31.
yeah. Page number 31. What is the topic? I have different
Yeah, yeah.
slides actually.
Yeah, the worst case of conversion time is equal to 2 to the power n. That one.
In which one? I think in
Yeah, counter type ADC.
hmm, yeah, counter type ADC. No? Hmm, hmm, tell me.
Sir, as we reset the counter at 0,
Hmm,
at the max it should go.
hmm, yes.
Yes, sir. As we reset the counter to
Hmm,
0
hmm,
before the conversion starts,
hmm,
as it goes till the Vn is greater than VDAC,
hmm, hmm, hmm,
as it as it crosses that, it stops
hmm, hmm,
conversion.
hmm, hmm. Right.
It means then how could we say that it means 2 to the power n means 0 to 2 to the power n minus 1 it
No,
will
don't
go.
think like that. For example, let's say you have a V in of 1 volt. Okay. How many clock cycles it will take? It will take
1
only one.
volt, what is it?
It will take only one clock cycle, right? Because it is
Correct,
already
correct.
reset 0.
Ah,
So,
ah,
and the maximum this V in can go is 255 because it is 8 bits.
hmm, hmm.
So, what is the
2
maximum
n
number of
minus
clock
1.
cycles? Yeah, 255. So, that's why it is 2 to the power minus 1 because
Correct.
at reset it is already 0, right?
Hmm, hmm.
That's why.
Correct.
Hmm.
Sir, but that's what it means 2 to the power n it is written over
No, I know that
there.
it's written, but maybe you can. I mean, see, what happens is in 2 to the power n minus 1, when n is very, very large, let's say n is 32.
Okay,
Okay.
in that case it has written.
Correct. So it is there is not much difference between 65535 and 65536.
Okay, okay. It means
That's why.
it will be so minimal that.
Yes, yes. But it is always 2 to the power n minus for counter type ADCs. For
Okay,
SAR
sir.
it is n.
Okay, sir.
For
One
SAR it is
different
n.
question is that
Hmm.
what I had question. I had question that's what's
Yeah.
the difference between sir multitasking, multi-programming, and multi-processing? These three, sir.
Okay. See, multiprocessing. I understand, but can we? I mean, keep this question for the next session. It is already 8:30, and I have to go for.
Yeah,
Uh,
okay, okay, okay. Thank you, sir.
yeah, yeah. No,
No,
but
sir.
you
Actually,
keep. See,
this question was.
I'll tell you. One is this multiprocessing, one is this multi-programming, okay, and one this multitasking. So when you say
Yes, sir.
multi-programming and multitasking, they are both the same thing almost. Okay, normally. Okay,
Which one, sir? Multitasking
multi-programming
and
and multi-programming and multitasking. Okay,
okay,
see in multi-processing, what we have is number of processors. I mean, there are multiple number of processors.
okay,
Okay, in multitasking, we have one processor which is doing multiple tasks.
okay,
Okay, and multiple programming, they are sometimes called as, for example, they are sometimes referred to as multitasking, but I'm not aware of any other, for example, terms that are associated with this multi-programming or any other
Okay, thank you,
concepts.
sir.
Okay. But
Thank
I
you, sir.
think
Thank you, sir.
the two most popular and widely used terms are multiprocessing and multitasking, and rest are all derivative terms. They are
Okay.
all derived in some way from this either multiprocessing or multitasking, because there is no other possibility. As per the current
Yes.
technology that we have, we don't have any other possibility.
Okay, sir. Thank you, sir.
Okay. Okay.
Thank you.
Thank you,
Thank you.
guys. Bye bye. So I'm signing off. Okay.
Yes.
Yeah, sir. Thank
Okay.
you.
Okay. Okay. Bye bye. Bye bye.
Thank you, sir.
Thank you. Thank you.